Welcome back to the Fullerton College Pre-Press class. This is Ben Hewitt, your instructor. We are picking back up where we left off in the PIA Pre-Press Training System, Module 5.2, and we're talking about paper. I left off kind of awkwardly in the middle of the thing last time because I ran out of time on our recording, but here we are again talking about grammage versus basis weight and defining the thickness and weight and just how to define what kind of paper it is you're using. The advantage of grammage versus basis weight is it is directly comparable no matter what kind of paper you're using. Remember that basis weight is based off of the weight of 500 sheets, sometimes less for a few specialty stocks, but 500 sheets of the parent size. And the parent size varies depending on the use of the paper. So text or book paper is somewhere around 25 by 35 off the top of my head. I can go back and look at it to double check that one. Let's get this correct. 25 by 38. And cover stock is 20 by 26. Duplicator paper and copy paper is 17 by 22. So there's three different sizes of paper, and all of them need to be reconciled. And one of the other awkward side effects of that is there is some paper out there that has two basis weights. There's some paper that's either lightweight text or heavyweight duplicator paper. This is where you have 24-pound, bond is the word for the duplicator paper. 24-pound bond is the same thing as 60-pound text. So if you buy 24-pound paper, it's 24/60. There's also 28/70 and 30/80. I'm forgetting that last one. Don't quote me on it. I might be wrong. But anyways, so people will still order stuff by basis weight. People will still say they like 100-pound text or 80-pound text because it's hard to ditch a legacy measurement if you're used to it. One of the reasons the metric system never really took off in America, even though they tried when I was a kid. They're like, yeah, we're all going to learn this. But intuitively, we all know what it feels like to drive a mile. Intuitively, we don't know what it feels like to drive a kilometer. We have to go, well, it's 0.6 or so of a mile and do the math. It's not the same. We think in imperial or traditional English measurements, and then we convert to metric. We don't think in metric exactly. Anyways, moving on. So the grammage, 80-pound book is 118 grams per square inch, and 60-pound cover is 162. So with grammage, it's very intuitive. When the numbers go up, the paper is thicker. End of story. Paper grain. Yeah, this is another one of those important ones. And this is the one that we watched our Mythbusters video that's semi-related about folding paper, because it's far easier to fold with the grain than against it. So wood has a grain. And if you look at a piece of wood, all the grain goes one direction, which if you're talking about a tree trunk is up and down. It's what makes trees stiff and not floppy like grass. They have this grain, these fibers that make them stand straight up. That grain of the wood, although you remove a lot of the pieces in between it, those fibers that make up wood grain turn into paper, and they still maintain that grain direction, assuming that you made it on a paper making machine using head boxes, slices, and Fourdrinier belts. If you'd use the traditional pre-industrial paper making method and achieve something called laid paper, then you do not have a grain direction. If you ever go out to a goods store and buy good, high quality origami paper that is traditionally made the way it's meant to be made in Japan, that is also laid paper. Laid paper, because it's never squeezed through that slice in the head box, has random grain orientation throughout the page. And it does not have a predominant grain. It just has random fibers every which way, kind of like a felt, if you look at how felt is versus fabric. Which means for good origami paper, you can fold it in literally any direction equally well. That's the difference between good origami paper and doing it out of cheap notebook paper. It will be far easier to fold one direction than another. Now, it's very important to understand grain direction as you work with printed products because it affects the final output. Your grain direction affects how you can fold it and how you can cut it, what sorts of edges it will hold, which direction it will stand up or not stand up, and it can either make or break a print job. There's one that I love to point to at our own campus, if you guys have been on it lately, where they have these full page. Isn't it funny how we call it full page when anytime you have a single sheet, it's a full page? An 8.5 by 11 letter size page of these brochures for different programs on campus, standing in these little cubbies on the walls in the different hallways, and they were printed with the wrong grain direction. So instead of standing up in their little slots, they all fold and flop over their little slots and kind of bow down to you when you walk by. While I appreciate the honor of having the papers bow to me, because honestly, paper is my kingdom. Don't quote me on that. But other than that, yeah, it should have been the other direction. Big went cheap and used the wrong grain direction just to be sloppy about it and to save some money. And the end product didn't stand up in its little card holder like it was supposed to. Now, if you're going to fold it, you want to make sure that the folds go along the grain lines. Folding against the grain is harder and it causes the paper to crack, and it doesn't make you a nice of a crease. So paper grain happens. I know I'm just karaokeing the PowerPoint here, sorry. But when you spray the wood pulp out of the slice through the head box, you find yourself with the grains aligning into one direction. It also then aligns with the direction of travel of the belts as it goes and kind of helps that along as well. So all the fibers from the wood find their way into the paper, and they still line up if you made them the industrial way. So fold with the grain, always fold with the grain. Trifold brochures and the like, you want to make sure they're folded the way the paper grain wants to be. They will fold so much neater and stay closed. If you fold across the grain, perpendicular to the fibers, the paper can crack, it won't fold even, you get weird edges to your folds. It's not a great thing. Anyways, the grain direction has to do with which way it goes. On paper, you can have a long grain or a short grain on it. Long grain means the grain goes, assuming your paper is cut into a rectangle and not a perfectly symmetrical square. If you have a rectangle of paper, you have a long edge and a short edge. Long grain paper has grain that goes the direction of the long edge of the paper. Short grain paper has paper that goes along the short edge of the paper. And you can see on here, it even does bow a little bit. It'll want to warp between the grains. So the grain direction will stay stiff while going across it will be folded easily. So what was I going to say about that one? On digital printers, since all the paper is fed through a roundabout, twisty, turny path around a bunch of different rollers and up and down different chutes and things, short grain paper works better in digital because it needs to be able to bend and warp around all those rollers. If you're printing offset, it doesn't matter as much. It matters then about what your finishing your finishing processes will be, because it'll have to deal with the folding and the cuttings. But if you're running on a digital, like a Xerox or a Canon or something, you want your paper to be able to roll through the feed system and bend and flex and go through there, because the paper path through there is not straight. It's like an intestine. It goes with twisty, windy all over the place to allow a longer line to fit in a smaller space. If you're choosing paper for something like a book or a complicated fold, you want to make sure that whatever your last fold is going to be is along the grain, because it'll be hardest to fold that last one when the paper is the thickest. So you need every bit of help you can get. If you're going to print 8-page signatures, you should be using short grain paper. Now, sometimes people will use the wrong grain, either by accident or on purpose, to save money, because sometimes you're not going to get as many sheets out of a parent sheet depending on the grain direction. So you may be able to get 9 instead of 8, but it's going to have a cost of utility. It might just not work. Then you want to also match your paper to your press, because there's multiple types of presses, and it's all based off of their feeding systems. Whether you're running offset or, well, actually, this is just really talking about offset. Let's be honest here, because Flexo is basically a web all the time. There's basically two things. There's web-fed and sheet-fed presses. Web-feds feed off of a roll. And it's hard for me because I want to be professional here, but I cannot unsee the image of a roll of toilet paper. Every time I see a web-fed press, it's stuck in my head. It's there. I may or may not have applied many of these rolls to people's houses as a kid. Anyways, it looks like a roll. They call it a web. Sheet-fed means it picks up individual sheets. You put a ream or stack of paper in it, and it picks it up off the top and pulls it in. Anyways, you need to make sure you're buying the right kind of paper. If your press wants to run from a roll and you try to give it a stack of paper, it's not going to be able to do anything with it. Same thing goes if it's meant to hold individual sheets. The system that causes the paper to move through the press will be unable to pull a roll through. It'll just jam and break. So the paper must match the press. Let's pause here and I'll do one more video where I talk about the two types of presses on their own, because it'll be more logical.